Okay. Welcome again. So welcome to the first edition of the SKCAM workshop, hopefully the first of many. The idea of the workshop was born probably last year during the last FSC in Leuven, where we met with a group of people interested in automated cryptanalysis and modeling. And we decided that we should join forces to grow this field of research. And among the several efforts we've been discussed, we said why not meeting and share our research together in a more informal way. And so here we are 1 year later organizing this workshop. So the day is divided in, I would say, mainly two parts, the morning and the afternoon. In the morning, the focus will be more on tools for automated cryptanalysis and modeling, while the afternoon will be more about theoretical results. In particular, in the first three talks, we'll be talking about a tool that we have been developing at the Technology Innovation Institute in Abu Dhabi. Actually, two tools. One will be a platform that I will briefly explain, and another one will be a library to perform automated cryptanalysis. So I'll be sitting because I need to work on the laptop. So if you are way in the back and cannot see the details, I encourage you to come forward because I will not have slides. I will have to share Jupyter notebooks. So the resolution might be a bit small if you are far away in the back. We'll try also to register all the sessions, so hopefully you will have a chance to review them once you're back. So when you entered, you might have noticed that there are some booklets on the table before the door. So these booklets were from last year. We printed them for FSC. So they were essentially like a small, we can say, advertisement of the CLASP library. And inside, you can find a few examples of how to use the library to perform cryptanalysis tasks. So last year, you will see in this booklet, there is a link that says clasp.tii.ae. So this is not the CLASP library. This is the web application that we developed because one of the main issue we noticed when, in general, not just for CLASP, but for cryptographic libraries developed by researchers, is that they are very hard to access. Sometimes they are not maintained. Installation, it's always a pain. So we said, why not preparing a platform where all these applications are ready to use and you don't have to spend 1 second trying to understand how to install them. So we started with what we call the CLASP Web, which was this application that we were advertising last year. But then time passed by, and we said, I mean, CLASP Web can host not just the CLASP, but can host also other tools that other people develop. So we said, let's rename it and let's revisit the mechanism of the application, and that's why we came out with what we call now DojoCrypt. So DojoCrypt, besides making this available to people outside, we also use it internally at TII. So what is it, this application? It's something that you can deploy on a cluster of servers, and you can deploy, let's say, a sort of virtual machine, choosing one of the servers, and it will set up all the environment for you. In a few moments, I will show you how this works. So we heavily use it internally in TII with our cluster of servers, and now we made it available on an Amazon cluster with a few nodes that will be available to the public for free. So I think you might have received the email, I hope, that I sent yesterday, where I encourage everybody to register. I hope there was no issue. We didn't receive any email or any, let's say, no request for help. So I assume that the ones who tried, everything went smooth. So the platform, you can find it at dojocrypt at TII, dojocrypt.tii.ae. It will redirect you to this URL, app.dojocrypt-tii.com. And here you will be prompted to a login page, and you will be able to register. So the platform is very simple. There is really nothing complex in that you can find. Once you log in, you will enter your dashboard. To be fair, when you enter the first time, your dashboard will look like this. It will look like an empty page where you cannot do essentially anything except click one button, which is the new deployment. So you click the deployment, and this will create a deployment for your user. This, you cannot change it. And then you will be able to choose an image. So this is the internal deployment we have in TI. So there are many images you can see. The one that you have on Amazon only will have a few of them that I will show in a bit. So this is just to show you that all these images are usually predefined setup for an environment that we want to use when we want to do some particular research. So, for example, we have some setup to use Gurobi, something for fully homomorphic encryption, something for password recovery. So we have really a lot of images. So this is not even the full list. But let's say once you will go on the Amazon version, oops, sorry. The only images you will find at the moment are the ones in this list. So these are the tools that are of which some of them we will talk about them in this workshop. Some of them are very similar to the ones we are going to talk about in this workshop. So that's why they are here. So for now, I will not create the deployment live because it takes a few seconds. I already created them before. Only to notice one thing: once you a bit zoom, okay. Once you create a deployment, you will see one new card appearing under your deployments. For let's say cost reasons, we allow users only to create one deployment at a time. So it means that if you created a Clasp deployment and then you want to test a Tagada deployment, you have to delete the Clasp deployment first and create the Tagada one later. So you see I have 4 cards here because I made myself a special user, but like the normal user will only see one of them at a time. So what can you do with these cards? So you can go to your workspace, and you can do it in 2 ways. So either by clicking the workspace or through SSH. So I will not explain SSH because I assume that people who will want to do it with SSH are, let's say, nerd enough to figure out how to use it. But if you want to go to the workspace, which is my preferred way, you basically click on this link. First, you maybe copy this temporary password that is associated to your deployment. So you just click here, and then you click on the workspace. This will redirect you to a page. Well, it will ask the password, and then you can click submit, and it will enter the workspace. So what will you find in the workspace? Essentially, you will find, for those who are familiar, a Visual Studio Code IDE. So you will be able, so you will be able to perform all the usual operations you can do in a standard IDE. Actually, to be honest, this is called Code Server, is like a remote version of Visual Studio Code. But you see on the left you have the Explorer. When you click on a file, it will be open in the main part of the screen. You can also open the terminal. So here, since I'm zooming in, not all these pages are there. Yeah, so this is the terminal. What do you find in the workspace? Essentially, you will find two folders. One is My Files. The other one is called Getting Started. The Getting Started folder is really the folder you should make a friend, because it contains like small tutorials on how to use the tools that are listed here. So for now, we put very short tutorials of Cascada, CryptoSNT, and Tagada, and more extensive tutorials on Clasp, because it's the tool that we are developing the most. But we are welcome to, let's say, if you know these tools or if you know how to use them, you can share tutorials that you want other people to see. So what important thing, the Getting Started folder is read-only, so you cannot write files on this folder. You should write your files under My Files, which is fairly intuitive, I would say, but there is also a caveat. So if you can write also files in other locations of the deployment, but the only files that will be persisted when you delete the deployment are the ones under My Files. So if you create, so now if I create, let's say I go under my home, I have my name, and then I have another folder. The Getting Started folder is read-only. I have, for example, the Cascada folder. I can write files here, but if I delete the deployment, this will be lost. So you should really write them only under your username. Oh, sorry. Under My Files. So this is the folder where you want to write and save your work. Okay, so that said, let me go back to this deployment that I prepared. And let's see what we have in the Getting Started folder. There is a main README file. The main README file will give you an introduction to DojoCrypt, and mostly will help you orient yourself in the Getting Started folder. It will explain that you have examples and tutorials for each tool. It will explain you what I just said about the workspace, the fact that My Files is the place where you want to store your images. And then it will explain you what is the deployment. And notice that if you want, maybe it's obvious, but if you want to use, I don't know, the Clasp tool, this will not work on the Tagada image, for example, and vice versa. So you have to, if you want to use the tool, you should choose the image where the tool is installed. We also tried to build one image with some tools put together, but this is not always trivial because of dependencies of the tools. So we'll also give you some hint on how to do the connection through SSH, and some ideas on how you can contribute to the project. Of course, if you have any question, you can go on the Contact Us section in the main page of DojoCrypt. So now I'll take the second part of my talk to discuss, to give you an introduction of Clasp. So I will navigate inside the clasp folder, starting from the README file. So the README file will simply tell you that there are 3 folders inside the clasp folder and what you can find inside of this folder. So first there is the folder called Introduction to Clasp. And as you can imagine, this is probably the best place to start if you want to learn about Clasp. We'll see in a few minutes what is the content of this folder. Then there is the Did You Know That folder, which is essentially a list of short script that you can find also in this booklet, maybe with more details. Here we only had a subset of the ones that you can find here. And then there is a folder called Tutorials, where you can find more advanced tutorial that we will keep updating. So for example, my colleagues will also present some of the latest advancement we did in CLASP this year. And the tutorials that they will show are not there yet, but we will upload them probably in the next few days. So let's start by going inside the Introduction to CLASP. So Introduction to CLASP contains several things. I don't want to go through all of them, but I just want to give you a brief overview and then see a few of them. The best file to start with is probably the CLASP overview. This is just a markdown file that gives you a bit of information about CLASP, and we'll go this in here in a bit. Then there is a basic introduction which is mostly a Jupyter notebook. Yeah, I have to say that all the files that you find in the Getting Started folder are either Jupyter notebooks or markdown files, because they are say very easy for a user to read and follow along. So yeah, in the CLASP basic introduction, you will find like very basic introduction of CLASP. We will see how to construct a super simple cipher with only one component and things like this. And then there is another notebook that will implement a block cipher, a toy cipher that is a little bit more complicated, but still very basic. Then we have a sample implementation of a full block cipher, in this case AES 128. So you can use it as a reference to see how you can implement a full block cipher. You have some toy ciphers as examples, like a toy AES, a toy Feistel, toy SPN, which is kind of similar to the toy AES. And then I personally find very interesting the introduction to differential cryptanalysis of the block cipher companion book. So we implemented all the say exercises that are given in that book in CLASP to show also how to use it. And I really recommend to give it a look, because it's I think it helps you understand not only about CLASP, but also about differential cryptanalysis. So you can use it if you are a professor in your lessons. And this in particular, this you can find it here. So you can in the book there is a definition of few toy ciphers, and every time with a more complex adding some complexity to the structure and then performing the cryptanalysis. And finally, we have a folder that explains how to evaluate a cipher in CLASP, but this I will come to this in a bit. So let's go with the CLASP overview file. Let's open it in preview. So CLASP, for those who don't know, is it's a library that has been thought for helping us symmetric crypto analysts to perform tasks that are usually very long or error prone, and sometimes not so easy to do. So, for example, finding a differential trail of a cipher is something that is not trivial, but in Clasp you can do it with maybe 3 or 4 lines of code. It's meant to be generic in the sense that we want to be able to implement as many ciphers as possible. So we included a list of components, where a component for us is like a XOR operation, an S-box, a linear layer. So we have a full list of components that can help us build more than 80 ciphers from the literature. You can find the Clasp repository in GitHub. It's under the GPL v3 license because Clasp is heavily dependent on Sage, so he inherited the same license. There is also a read the docs page and the first paper about Clasp, but I wouldn't recommend to start from those because, well, the white paper is now a bit outdated. It was like the very first version of Clasp, and read the docs is like an automatically generated documentation that we didn't maintain very much. So my recommendation would be to look at the repository or the Getting Started folder that you can find in DojoCrypt if you want to learn how to use Clasp. So the library was the development of the library started back in 2019, so it has more than 6 years. More than 50 contributors and collaborators put their hands on the library under different aspects. It was made by students, software developers, DevOps engineers, and so on and so forth. And the main founder of the library at the moment is TII, the Technology Innovation Institute, where I work. And in the years, we had several contributions also outside the center. I have to mention probably one of the main contributors outside TII is the University of Milan, of which we have some representatives here around. In particular, thanks to Professor Andrea Visconti. But then we had also collaboration with Radboud, with Nanyang NTU University of Singapore, with Roma 3, recently with Marco, and LeanMind, which is not a university, it's a software development company that was hired to help us in some process of the development. So there is here a section on how Clasp compared to other tools, but please consider it work in progress that I'm planning to update during these days, especially while I'm learning about other tools. So I will not go through this now because I still want to update it. There are still many things that I don't know if other tools can do. I hope to know it more and to complete this comparison later. I can tell you a bit more what Clasp can do. So at the moment, as I mentioned before, it has more than 80 ciphers implemented, symmetric ciphers, which include block ciphers, some tweakable block cipher, permutations, hash functions, and stream ciphers. And and you can build any cipher that is using a subset of the components that are listed here. You can Clasp in Clasp. The idea of Clasp is that you represent or implement a cipher using a particular representation. And the cipher, from the cipher object, which is a Python object, you can perform some manipulation on the cipher or run some tests on the cipher. And this all, let's say, automatically. In particular, you can select subcomponents of the cipher. You can remove part of the ciphers like the key schedule, or you can invert the cipher, which can be useful in many cryptanalysis attacks. You can also analyze the properties of the components, which is maybe not one of the most interesting features, but still is there. Then you can convert the cipher, the Clasp representation. You can, let's say, compile it into an actual executable code that can evaluate the cipher. meaning that you can compute the encryption over a given plain text and key, for example, if it's a block cipher. And you can do it in different languages. So you can compile the representation to a Python bit string or at a Python NumPy implementation, which is very useful if you want to evaluate multiple plain text at the same time, which is a very useful thing, especially when you want to do neural cryptanalysis. You can also compile it to C in different flavors, and we are also working on a CUDA version of the ciphers that will allow us to evaluate multiple instances of the cipher at the same time using GPUs. Then you can run avalanche and statistical tests, in particular statistical tests in the sense of what it was done back in the AES competition when they were evaluating how ciphers behave when used as pseudo-random number generators. You can run avalanche tests, which are usually preliminary tests to evaluate the diffusion of the cipher, and continuous diffusion test, which is maybe something that is not so well known technique that I cannot explain now. But if you're interested, we can discuss it offline. You can model the cipher as a system of equations. And then you can try to solve the system. For example, you can fix some of the variables and try to retrieve the other variables. So, for example, this allows you also to perform a sort of key recovery attack. Of course, if the system is not too complicated or if you know enough variables. And then maybe one of the most interesting modules of CLASP is the models module, which is the one that allows you to build a distinguisher. So CLASP at the moment supports different features. So you can find one trail for a cipher, linear or differential, depending on the kind. You can fix the weight of the trail that you want to find. You can find all trail given a fixed weight or that have a weight at most a certain value, or you can find the lowest trail given a certain weight. Sorry, the lowest trail, lowest weight for a trail. And you can do this using different kind of solvers. We have SAT, SMT, MLP, and constraint programming solvers. Well, CP is mostly, I would say, mini-zinc module. And here you can see the list of all the type of distinguisher we can at the moment compute. One other module that you can do is neural distinguishers. Neural distinguisher will be explained later by David, so I will not say much about it. And then one other nice feature of CLASP is that all the outputs that you get from the results, you can easily convert them in LaTeX tables, JSON dictionaries, pandas data frames, and you can have interesting plots. So there are also, of course, a lot of things you cannot do in CLASP, and maybe I list them here. This is a small subset, but it could be a good input for you. Maybe if you don't know what to do in your research or in your free time, you can help us contributing to the project by developing one of these features. In particular, I think something very interesting will be to have support for algebraic ciphers, because at the moment we don't have this, but they are, let's say, a very big branch of symmetric cryptanalysis in the last years, especially for these MPC and FHE applications. Okay, so I don't have much time to go to the basic ideas of CLASP. Let me just briefly show you how you would implement a cipher. It should be really 2 or 3 minutes, and then we can go on to the next talk. So this is one of the toy ciphers that we have. We call it toy SPN1, where basically you have a plain text of 6 bits and a key of 6 bits. A XOR with the key, 2 S boxes of 3 bits, a shift of 1 bit, and then again the next round is the same. So it's a very simple cipher. How would you implement it in Clasp? So you create a class in this way. So you give it a name, a type. Then you can set as many inputs as you want. But if it's a block cipher, I encourage to use the keywords plaintext and key because some features require these keywords to be used. You set the size of the two inputs and the size of the output. Then you have to add a round, and all the components that you will be adding after will be assigned to this round. So for example, here I'm adding a round, I am adding a XOR component, the 2S boxes, and the rotation. And when I add a component, I need to specify which are the input of this component, and these are given as a string. In particular, the first two input of the XOR are the plaintext and the key, and I have to say which bits of the plaintext of the key are have to be taken. In particular, here is from bit 0 to bit 5 for both the plaintext and the key. And then I have to specify the output size of the component. So this is how you add a component in general. So you see for the XOR, I need to connect it to the, sorry, for the SBox1, I need to connect it to the XOR by taking its ID. I connect it to the bit 0, 1, 2 of the XOR. The output of the XOR is 3. And then I pass the value of the SBox here. Similarly for the other components, and one other component is important is what we call the round output component. So this is not really a component of the cipher. It's mostly a tag that tells you I want to have information at this at this point of the cipher. So when, for example, compute a trail, you want to know the value at the trail. So I could add, for example, an output component also after the XOR or after the 2S boxes if I wanted to have more information when I print the cipher like this. And similarly, for the very last output of the cipher, I have to add a cipher output component, which is essentially the same thing as the output component. Then I instantiate the cipher like this. I can create plaintext and key, and over the cipher, I can evaluate it over the plaintext and key and get the output. So for now, I will stop here. So there are many other features that I encourage you to look at. In particular, you can try to go to the did you know that folder. This is full of very short examples like the ones in the booklet. You can just copy paste the code here, try to understand it. It's very simple, and you can try to generate the plots that you want and see how if you find anything interesting. But now my colleague Juan will present. Juan and David, sorry, they both will present some of the new advancement we did in Clasp this year. In particular, we added I think the first fully automated model for differential linear cryptanalysis. Then we have a model for impossible differential trails, and first, as far as I know, division property fully automated search. So I'll leave the word to Juan to present.